This is the Building Automation Monthly Podcast with Phil Zito, episode 121. Hey folks, Phil Zito here, and welcome to the Building Automation Monthly Podcast, where we are going to be discussing information technology. So we're in the middle of a 4-part series on IT networking. So how do networks and all the parts and pieces within a network work with a building automation system? And if you're new to the Building Automation Monthly Podcast, awesome. Welcome here. Glad to have you here. And what we're doing right now is we're going through kind of one of the topics that's really difficult for a lot of folks because there's just not that great of training out there. I mean, we've got a training program that we have, but outside of that, there's not really anything made for BAS folks around networking. So what we're going to be doing, and what we have been doing both in episodes 119 and episodes 120, is going through the first kind of 4 layers of IT networking, looking at how building automation systems work within these networks, and then talking about kind of the terminology and functionality you need to understand. Now, the reason why we're doing this was really well articulated last week when we were having our live office hours calls for our students. And one of our students was running into a problem. See, he had a commercial office building that the customer does not have an IT department. And they've purchased these Belimo IoT valves. And basically, for those of you who don't know, Belimo has this kind of valve series, and Belimo is a valve manufacturer for hot water and cold water valves. And they have these kind of IoT valves. There's a fancier name for them, but basically what they are, they're a flow meter, 2 temperature sensors, and then a valve. And essentially what it does is it monitors the delta T and the flow to be able to calculate essentially the BTU loss or gain across a coil. And the whole purpose of this is to measure and control efficiency of coils. Now, it's a really cool product. I really like it. It's a little bit on the expensive side. So if this is a kind of building where you're not the primary occupant or you're not going to be there for a long time, the ROI might not be there. But on long-term buildings, the ROI is there. But this isn't a podcast about the Belimo IoT valve, although I think I'll get the folks from Belimo on to talk about it because it's a pretty interesting case study of real IoT. But what it is a conversation about is, so this customer comes to our student and says, hey, we've got this network, and this network has 2 VLANs essentially on, or at least they want 2 VLANs because in their mind they need 2 VLANs. And the Belimo devices, they have their own IP address range. And then the customer says, hey, what is on our network? Because we don't know. And we want you to put all these IP controls on our network, but we're not quite sure. So we were talking about how do you go and find what's on the network? How do you discover that? How do you then secure that network? How do you go and plan out IP address range? How do you go and deal with switching from a public IP to a private IP? How are you handling that? What if the customer wants to use unmanaged switches, which is something we discussed in our previous episode, the difference between unmanaged and managed switches. What if they want unmanaged switches because they don't want to have the cost or the complexity of managed switches? Now, if you're feeling a little overwhelmed, which, you know, it seems like you're probably feeling a little overwhelmed right now by all this concepts and terminology that we just laid out in front of you. That's okay. The good news is that after this episode, that feeling will be much less. I don't think it ever goes away with IT. IT changes quite a bit. And myself, personally, having 2 master's degrees in IT, several certifications, having run the integration arm for Johnson Controls, the technical integration arm, building integrations, building prototypes, I will tell you that even with all that experience, you still run into things where it's just like, huh? What? So it's always a process of learning. However, there is some foundational knowledge that we need to have in order to effectively work with networks. So as I mentioned, the past 2 episodes, we talked about the physical networking in episode 119, and in episode 120, we went through kind of the data link. And, you know, those episodes were not the most entertaining ones, but they were extremely valuable because they gave us solid concepts that we need to understand in order to truly appreciate this episode, which this episode is for any of you working with IP controls, for any of you working with IP sensors, for any of you working with IP supervisory devices. Listen up, take notes. This is going to be a very important episode for you. Even if you're just in sales or you're an engineer and you're feeling like, man, I don't need to know all this technical stuff. I can't count how many sales folks have gone through our IT course because they knew that the closing the deal, closing the sale was dependent on IT. IT wasn't the decision maker, but IT could say no. And they knew that they were going to be sitting down next to IT and they had to have at least a little bit of credibility so that way they could have a conversation with the customer and with IT and get past kind of that gatekeeper essentially. So even if you're in sales or engineering, this is still very important for you. Okay, so let's dive in. So as I mentioned, we are going to be discussing IP, which is the Internet Protocol. It's layer 3 of the OSI model. If you don't know what OSI model is, listen to episode 119 and 120. It'll make complete sense after that. Really recommend you listen in that order. So if this is your first time listening to us, I really recommend that you listen to episode 119, 120, and then 121. That being said, we're going to discuss IP. We're going to discuss IP architectures. How do you lay out these new IP controllers that are all the rage in the marketplace right now? Well, first we need to get some IP concepts down, okay? We have this thing called the IP address. So if we recall from episode 119, we didn't have necessarily an address. We just used a physical medium, a wire, to connect our devices because we're focused on wired, not wireless in this 4-part series. Then in episode 120, we talked about how we had a physical address called the MAC address, the Media Access Control address, if I'm remembering the acronym right, which was the physical address of our network interface card, which is what allows our host devices, our controllers or supervisory devices, etc., to connect to the network via typically a switch. So now we're talking about IP addresses, and IP addresses are logical addresses. These are addresses for our hosts to communicate to other hosts either in the local subnet or outside the local subnet. Don't worry, we haven't discussed subnets yet, but we will be discussing subnets in great detail. Okay, so we've got IP addresses. What are they? Well, essentially what an IP address is it is a logical address, meaning it's not a physical address. It is not physically tied to a network interface card like a MAC address. Rather, it is a logical address. So it's an address, you can have an address like an IP address get assigned to multiple devices. Now, here's the deal. Within this thing called a subnet, which is a sub-network, it's basically, if you think about it this way, right? The whole internet is a pie. And as you cut slices of that pie, because I think there's like 2 billion IP addresses in the addressable range of the internet, public IP addresses, which we'll talk about public IP addresses in just a second. This is a huge topic, so this might be a fairly long episode. But with that being said, think of this pie. And you cut out these pieces of the pie and you set them on plates. Well, what you're doing is you are then creating subnets. You're taking a little bit of that addressable range and you're creating these subnets. And then in order for one subnet to communicate to another subnet, it needs to know how to get to that subnet. And that's called a route, because what happens is each subnet has an IP address range. Just like a zip code has a certain amount of houses inside it, a subnet has a certain amount of hosts inside it. And how those hosts are determined, the amount of those hosts, is by the subnet range. Okay, and so there's a longer term for it that I'm not going to get into, but basically you'll hear, oh, I've got a /24 subnet or a /25 subnet. Essentially, an IP address is made up of 32 bits. That's ones and zeros. So when you have an IP address like 192.168.0.1 or 192.168.0.100, that IP address is 4 sets of 8 bits. Okay? Basically what happens, for those of you who are techs, this is going to make complete sense. For those of you who are in sales and engineering, just stick with me. Trust me, we'll get there. But basically, if you think about a field controller, right? And if you've ever worked with BACnet MSTP field controllers, you've probably seen the little dip switches on the field controller. If you hadn't, go and take a look at one when you're in the shop next. Just whether you're in sales or engineering, just get a controller, take a look at the addressing on it. For the BACnet MSTP, most likely it has dip switches. And how those work is each dip switch has a value. Typically, dip switch 1 is 1, dip switch 2 is 2, dip switch 3 is 4, dip switch 4 is 8, and then it goes 8, 16, 32, 64, 128. And what happens is if that dip switch is on, you have that number, whatever its value is. So if I wanted to do 192, then I would turn on dip switch 7 and 8. So that would be 64 and 128. And that would give me, when you add 64 to 128, that gives you 192. And so what's going on with an IP address is it's 4 sets of 8 bits. And if those bits are on, then those bits get added up. And the ones that are on, the values of them get added up, and that forms the number in between each of the dots. That's why it's like 192.168.0.100. And so how that is determined is by which bits are turned on. Now, why do I tell you all this? You're probably like, okay, what does this have to do with anything? Well, what it has to do with is we have 32 bits, right? And we have what are called network bits and host bits, okay? Now, as we recall from episodes 119 and episodes 120, our hosts are our individual devices that connect to a network. So if I were to tell you that I had, and we know we have 32 bits total, right? And I said we have a /24 network, then how you would determine how many hosts you have is you would subtract 24 from 32. That would give you 8. And then you would do 8 to the power of 2. Or rather, 2 to the power of 8. Yeah, 2 to the power of 8. And what that means is 2 to the power of 8 is 256. That means there are 256 because remember, each bit has got 2 positions, a 0 or a 1, an on or an off. So now we've got 8 or 2 to the power of 8, and that's 256. Now, here's where it gets a little bit more complex. We also have these things called a broadcast address and a default gateway. Don't worry, I will cover those in a second. But those take up 2 of our host addresses. So on a /24 network, we would have 254 host addresses that we could use, not 256. And then if we go to a /25 network, that would be what? Well, that would typically say, okay, so 2 to the power of 7. So we go from 256, what is that? So 256 minus 128. So it should be 128 hosts, if I remember correctly. Let me double check. I hate doing math on a podcast. Yep, so I verified it. It is 128 hosts, 2 of which are used because we have our default gateway and our broadcast address. So there we go. Now, these IP address, these host range, we are able to use them for our IP controllers, etc., etc. Now, we move into another topic, which is private versus public IP addresses. So public IP addresses are routable, which means that we are able to route to other subnets. So if I want to go from one subnet to another subnet on an external network, then I need to have a public IP. Now, you may say, Phil, why did you emphasize external? Because you can route on an internal network from one private subnet to another private subnet. I'm not going to get into private subnet ranges and things like that. It's something we do definitely cover in our IT course. But just realize that you have private IP addresses. Those are inside the network. And you have public IP addresses. Those are usually like the IP address assigned from your ISP. And then we use a capability, usually network address translation or port address translation, that allows us to convert from a public IP to a private IP range. That is a little bit beyond this episode. We'll talk about that in episode 122, where we start to go through ports and TCP and UDP and all that fun stuff. But in this episode, right, we're focused on IPs. So we have public and private. Private is usually what you're going to be dealing with as a BAS professional. And you're typically going to be asking for a set of IP addresses, a range of IP addresses. That's why it's so important to understand when you need 120 IP addresses, you may ask for a /25 subnet. That would give you 126 host addresses when we account for our default gateway and our broadcast address. In which case, you may say, hey, I want static IP addresses, which is the general preference in the world of BAS. Here's the deal. A lot of IT folks, they don't understand and they don't view our our BAS assets, our controllers or supervisory devices as, 10 to 20 year assets. They look at them as exchangeable assets like a PC or a laptop, which could be here today but gone tomorrow. Very short-term assets. And because of that, they have reluctance to go and give out static IP addresses. Which a static IP address is where you look at the MAC address of the physical device and you say, hey, for this MAC address, it's always going to get this IP address. That is static. Dynamic is where you have a pool of IP addresses determined by your subnet mask, your subnet size, and your pool of IP addresses is going to go and be used up through that dynamic IP addressing, meaning that as devices come onto the network, they get dynamically addressed. Now, for a lot of BAS protocols, that causes issues. A lot of BAS protocols don't play very nicely with DHCP, especially BACnet, where you have BBMDs they don't have to be, but they, in most cases, with most manufacturers' implementations of them, they have to be static IP addresses. They don't handle DHCP very well, which is dynamic host configuration. It's how we give out dynamic IP addresses. So we need to realize that when we're asking for static IP addresses, this is kind of why you need to understand this, because when you're working with an IT person, they're giving you a lot of pushback. You have to understand it from their perspective. From their perspective, you're asking for a bunch of IP addresses to be permanently assigned to these MAC addresses that now they have to maintain that assignment. They have to go and change that assignment. And you have to explain to them, look, this is not going to change for 10, 15 years. We're going to keep the same device. It's not going anywhere. This isn't a transient device. It doesn't move around. And you have to help folks understand that, because if they don't understand that, then they're going to have a real difficulty in going and giving you the static addressing that you require. Now, within a subnet, as I mentioned, we have a default gateway and we have a broadcast address. See, as we recall, in episode 120, we use broadcasts to discover devices on the network. And we discover those devices, and that is how we go about doing our messaging. BACnet IP, for example, is a broadcast address. The who is I am, who has I have services are broadcast. They're fire and forget. And it's really important for us to be able to support that. And to do that, we have a broadcast address. That is the address that broadcasts go about utilizing. All right. And then we have a default gateway. If we have an IP address, for example, if our device wants to communicate to another subnet, it obviously can't communicate to it on the existing subnet. It's outside of the subnet range. So let's say we have a device 192.168.1.10, and it wants to communicate to 192.168.2.10. They're on different subnets because they're both /24, meaning that everything before that last set of 8 bits, before that last dot, is a network. And that's how you determine that, right? /24, everything before that will be a network. So, or before the third dot will be a network because, right, each dot signifies, so 192 dot, that's the first 8 bits. 168 dot, that's the second 8 bits. 2 dot, that's the third 8 bits. And then .10, that's the host bit section, okay? So this device, the 1.10, wants to communicate to the 2.10, and it needs a way to reach it. It sends that message to the default gateway. That default gateway is usually what's called a router. Now, a router exists to route message traffic. It goes and says, oh, you want to get to this network? You need to go out this port, this physical interface. And then it allows that message to go to that subnet. See, routes can be dynamic or static. You can have static routes, which essentially are routes that say, hey, if you want to get to this network, you always go out this port. Or you can have dynamic routes, which use routing protocols that learn the routes and learn the networks dynamically, and then they constantly adjust. In our case, most of the time we're going to be using static routes and not dynamic routes. However, as you get to larger enterprises, you will see dynamic routes. Usually you're not having to set any of this stuff up. But it's really important to understand, because if you try to ping a device you try to ping 2.10 from 1.10 and you're not getting through, there's a couple things that could be happening, right? You could have a routing issue. You could have the wrong IP address, or you could have some firewall and port blocking issues, which we'll talk about ports and firewalls in the next episode. But in this episode, we're focused on IP. So it's really important to understand the routing. Now, realize I've laid a lot on you in such a short amount of time. So let's recap so far before we move into kind of the second part of this episode. So we talked about how we have IP addressing, and IP addressing is the logical address for our host devices. Once again, remember that we're using a lot of knowledge that we learned in episodes 119 and 120. So if these terms don't sound familiar to you, they don't feel familiar to you, really need to go back and listen to those episodes. And those episodes will really help the address one. These episodes are building upon one another. Okay, so we have our IP addresses, their logical IP addresses, or their logical addresses. They correspond with the physical address, the MAC address. So whereas a network interface card has a physical address, it also has a logical address. So we have our logical IP address, and that can be a public or private IP address and can be a static or dynamic IP address. It exists on a subnet, and a subnet consists of network bits and host bits, and that helps us determine what kind of network we're dealing with. It also helps us determine the range and the amount of hosts that we can have on a network. This is especially important when we move into IP controls, which are going to eat up a lot of IP addresses. So we've got that. Then we also talk about unicast and broadcast messages. There's also multicast messages, which we're not going to talk through. Unicast messages are direct messages between two hosts, whereas broadcasts are fire and forget messages sent to an entire subnet, usually utilized for discovery purposes. Talked about routes, which allow us to communicate between networks, and there can be static and dynamic routes. We didn't talk about VLANs, but VLANs take the concept of a physical subnet and they extend it across multiple physical switch segments. So basically what this is you can define a logical VLAN. It's a virtual LAN, by the way, virtual local area network. And essentially what it'll do is it'll assign an IP address range to several ports on a switch, but not all ports. And that is how you can have multiple ports across physical subnets being in the same IP range. This throws a lot of people for a loop initially because they're like, how do I have this IP range on this switch and the same IP range on the other switch? Shouldn't they be isolated to the individual switches to their physical subnets? Well, no, because we have the VLAN capability that allows us to have logical subnets that stretch across multiple physical devices. So if you're like, what the, which I know several of you are probably feeling that way right now, don't worry. It sounds complicated, but it's really not. And, this week's BAM TV episode will really help drive a lot of this home for you. For those of you, by the way, who are wondering what happened to last week's BAM TV episode, we got a new puppy here in the Zito house, and that puppy needed to be potty trained. And that was Phil Zito's job last week. And that is why we did not have a BAM TV episode. But that being said, we'll have the BAM TV episode for this week, so don't worry about it. And we'll have last week's episode as well. With that being said, let's move on to this IP for BAS architectures aspect. Okay, so something that we initially didn't have in our IT course, but we added it based on a lot of the questions we were getting, was a segment on IP architectures for BAS controls. Now, this is something a lot of folks have questions around because you have essentially 3 architectures. Now, for those of you who are familiar with these architectures, this is going to be, you're going to take some stuff out of it. So I would still go through it, even though you may be familiar with these IP address architectures. But you have 3 architectures, right? And they're called the ring architecture, the daisy chain or bus architecture, and the star architecture. Let's go through the star first. The star is point-to-point architecture. It's where you have a direct run from a switch port to an IP controller. It's the most expensive of the architectures, but it's also the most reliable because if that single access link goes down, it only takes down that one controller and not all the rest of the controllers. Also, you're able to use power over Ethernet in this scenario to power the controllers so that you don't actually have to run power to the controllers. And the real nice thing about this is that it is simple to troubleshoot. Now, on the complete opposite side of the spectrum from simplicity, you have the ring architecture, which essentially uses 2 ports, and you have a ring that is going in a circle and starts at one port and ends at another port. And the theory here is that if either of the links break, the other port can handle it. Now, the problem here is that each controller needs to have its own power source because you can't run power over Ethernet in series, at least not yet that I'm aware of. If someone's figured that out, I'd love for them to leave a comment on this podcast episode. But as of my knowledge of this in, it's July 2018, doesn't really exist reliably yet. So the ring architecture utilizes, in most cases, a address translation like NAT or PAT, which, as I mentioned, we'll discuss in the next episode. And it utilizes this to take one IP address or 2 IP addresses and extend that IP address range to all the controllers that are on the trunk. Now, it's also typically using a protocol like Ring protocol or something similar. And then finally, we have our daisy chain, which is very similar to MS. Oh, actually, let me go back. So the pros of the ring are reliability with cost reduction. So with the star pattern, you have to do an end run from the switch to each individual device. That eats up a lot of ports. Some switches for 48 ports can be upwards of several $1,000s. So in this case, you're reducing switching costs and you're also reducing cable runs. However, with the reduced cost, there is some reliability since you've got 2 ports. But if both of those go down, then you've got some issues. You also lose the capability of power over Ethernet. Then you have this daisy chain bus pattern, which is very similar to BACnet MSTP, where it's one controller after the other. And in this case, what you're doing is you've got Ethernet from controller to controller. You still have to have individual power to each controller. And if a single link breaks or you lose power to a single controller, you lose the entire network from that controller on. So there is a big issue. Whereas if you lose power with MSTP, you can continue communicating with IP loss. At least as of now, if you lose power, you lose communication downstream from that power loss. Now here's the issue, or rather, I've heard that folks are working on that issue and that a lot of companies have a fix or are almost done completing a fix and are going to roll it out. But for right now, that's something to be aware of when dealing with daisy chain. However, daisy chain is the cheapest of the architectures. It is also the least reliable of the architectures. So with that being said, that is IP. That is layer 3 of the OSI model, and that is what you need to know. I mean, when you think about it, right, you're going to go out on a job site. You're going to have to know how many IP addresses do you need? Do you need them static or dynamic? What subnet do you need them in? And how are you going to physically architect these devices, especially if they're IP controls? Once you understand those things, though, that's it. All this stuff about routing protocols and all this other jazz that, you know, folks are telling you to go get your CCNA and learn all that. You don't need to know that. I'm telling you, there's so much more. I've got this standing desk and I'm like bouncing right now because I'm so excited. I'm so passionate about this topic. But it's true because I see these folks that are spending hours getting their CCNAs and their MCSEs. And don't get me wrong, I mean, I did that. I went and got all those certs, right? But the thing is, I'll tell you, after having gotten those certs, after having gotten 2 master's degrees in IT, there's a lot that you learn there that you don't need to know because it does not apply. The reality is 95% of the IT groups out there are not going to let you touch their stuff. So why do you need to know it? You don't. You would be so much better off covering the basics of networking and then moving on, learning the basics of servering, servers, not servering, learning the basics of databases, learning the basics of remote access, the basics of cybersecurity. So much of what you need to do with IT is just being able to participate in the conversation. Yes, you do need to know enough to troubleshoot if there's not an IT group or potentially there is an issue. But most of the time, this will be enough. And that's kind of what we go through in our IT course. We cover exactly what you need to know about all those different domains, about networking, about servers, about databases, because that's what will overwhelm you. That's what will cause you to spend days and days on a task that you don't need to spend time on. So would really encourage you. We've actually got a free IT course that over a couple lessons gives you a pretty decent foundational knowledge of IT and would really encourage you to check out that course. So everything I've discussed, the show notes, the timestamps, the free course, the paid course, all of that is going to be available at buildingautomationmonthly.com/121. Once again, that is buildingautomationmonthly.com/121. And like always, I really appreciate having you here. From all of us at Building Automation Monthly, thank you so much for listening to our podcast. Thank you so much for being engaged and being part of the BAM Nation. We really appreciate having you here. We are so looking forward to all the great ideas that we've come up with and going to be bringing to you through the rest of this year. Thanks so much. Look forward to talking to you in episode 122, where we're going to wrap up this networking stuff with ports and TCP and UDP. Thanks a ton. Talk to you in the next episode. Take care.